Hello, Gabriel. Uh, Good to see you again. So, if you're there, let's start. Actually, it's our test parts. We have been talking about number and algebra. And first, we started by defining some numbers in math, right? Of course, everything starts with natural numbers or counting numbers and whole numbers. And we just expand this set, and we will add also negative numbers. We call them integers. And after that, also in some applications or real number problems, or even in theory, we may have to deal with parts, which is called a fraction. We call this a rational number. And we define rational number as a ratio of two integers where the denominator should be different from zero. And after that, we actually did a few examples about comparison of numbers, how to compare the magnitudes of numbers, right? And after that, other problems and linear equations and the word problems involving linear equations. So this test actually will cover all the questions from the past 3 weeks. Okay, let's start with this example. Of course, what I suggest to students actually dealing with this kind of problem is before you start solving this, first you need to have a look and give a little bit thought. Okay, how are you going to solve this question? It will save a lot of time. Sometimes students immediately, they just look at the question and start solving this, even they don't have a clear idea of solving this question or what method they are going to use. Anyway, but here, as you see, we have a lot of numbers starting from 1000 in descending on order until 1. But the signs are changing, alternating. We tell them they're alternating, but in twos, right? Not plus minus, but as you see here, the first one is, it is plus. Okay. So the first sign is plus, and after that we have 2 minus, 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 and plus, plus, minus, minus, plus, plus, minus, minus, right? Okay, so if I just keep this 1000, let's say equals, let me continue from here. Let me just keep 1000 here. And plus, after that, if you just combine these two numbers who have opposite signs, right? Here we have plus, minus, minus, plus, plus, minus, minus, plus, right? So what is 99 minus 998? It is 1. And minus 997 plus 996, it is minus 1. The same thing, 995 minus 994, it is plus 1 again, minus 1. And continue, right? And the last one is, what is it here? Because plus, minus, minus, plus, right? So here we have, let's see here, odd, even, odd, even, odd, even. So it will be like, then I can just actually make groups like this, odd, even, odd, even. Minus 4 plus 4, it is minus 1. 3 minus 2, it is plus 1. And here we have minus 1. And since actually we have 1000 numbers here, that means that we have 500 pairs. But I didn't pair this 1001, right? So that means the remaining numbers, this then 998. So how many pairs do we have here? Here we have 499. One pair is actually this negative 1 and 1000. So here we have 1 minus 1, 1 minus 1. They are all is equal to 0. Right? So here we have only 1000 left here, minus the last number, that's 1. So the result is 999. Another example, evaluate. Just write here solution. 13.672 times 125 plus 136.72 times 12.25 and 1367.2 times 1.875 is divided by 17.09. Okay. So if you notice here, these numbers, right, if you just actually ignore the decimal number, decimal point, they are the same numbers, right? So that means that the first one, 13.672, right? I can just write it as 13.672 is divided by, what is it? Is divided by 1,000, right? Times 125. And next number is 13672 is divided by 100 times 12.25 minus 13672 is divided by 10 times 1.875. And here we have divided 17.09. Divided 17.09. Okay. All right, so 13.72. Okay, so now I'll just going to write this as a fraction. Here actually everything is in parentheses, right? Actually, this division means that in math, let me just write here, A is divided by B. We can write it as A over B. Sometimes writing in fractional form actually shows this in a more simple form. Okay, so now what am I going to write here is 13,672 is a common factor. I can just take this out. Okay, so here we have 13,672. All right, and now here we have 125 is divided by 1,000. That is 0.125 plus 12.25 is divided by 100, 0.1225 minus 1.875 is divided by 10, 0.1875. And here over, okay, and also the 17.09, I can just write it as 1709 and divided by 100. But that 100, I can just write it here. Okay. So now actually, if you notice here, 13,672, 1709, actually, if you divide these two numbers, of course, we can just check that is it divisible or not. But if you divide this, actually, they have a common factor, right? So if you divide 13,672 by 1709, that's equal to 8. So here we have 8. And multiply these decimals by 100, bring this 100 inside the parentheses. So here we have, let me just write here times. Again, 100 times 0.125, that is 12.5 again, plus this one is 12.25, minus this one is 18.75. Okay. So from here, that's equal to 8 times, let me just do one by one, 12.50 plus 12.25, that is 24.75 minus 18.75. Now, which is equal to 8 times 24.75 minus 18.75, 0.75, that's equal to 0. 24 minus 18, that's equal to 6. So the final answer is 48. Gabriel, is everything okay? Are you there? Good. Okay. Next question, question 3. Let's use green now. I really like green sometimes. So what is it? Again, it's an operation or on rational numbers, right? To do this one first, we need to perform the operations starting from the innermost brackets. Here, the innermost brackets are this. And after that, this rectangular bracket, and after the division operation. So actually to add these things, but either I had to change improper fractions into fractions, or what is it? This decimal numbers into fractions, whichever is convenient for you. First, let me just remove the brackets. Okay, here we have 5 over 3 minus, what is 2 and 125? Actually, 2 is just 2, right? And 0.125 is, what is it? Is it 3 over 8, right? This if you divide 3 by 8, that's equal to 0. No, 125 multiplied by 125 is divided by 1000, divided by 1 over 8. Sorry, it's not 3 over 8. 1 over 8. 1 over 8. And minus minus, it is plus. Here we have 8 and 7 over 24. And divided, so immediately I'll just change this division into multiplication, multiplied by minus 6 over 5. Okay. So let's just simplify inside the parentheses first. See here the common denominator. Actually, if I add this 8 whole number minus 2, that's equal to 6. So here we have whole part will be 6, because I can write, if you're given a fraction a, we just write here, okay, a and b over c. That means it's a plus b over c, right? You can just write it as a whole part plus fraction part. So see here we have negative 2, right? And plus 8, that's equal to 6. And the remaining part is 5 over 3 minus 1 over 8 plus 7 over 24. And times, still here we have minus 6 over 5. So now if you simplify inside this brackets, the common denominator is 24. The first fraction to have this 24, we need to multiply numerator and denominator by 8. 8 times 3, 24. 8 times 5, it is 40. Minus, and to get 24 in the second fraction, we should multiply numerator and denominator by 3. 3 times 1, it is 3. Plus, the last one, already this denominator is 24, so we don't have to do anything here, just 7. Times minus 6 over 5 equals, now here 40 minus 3, it is 37. 37 plus 7, 44. So here we have 6 plus 44. 44 is 4 times 11, and 26 is 4 times 6, right? Times minus 6 over 5. And this 4 is gone. To multiply these two fractions, we have to change this fraction into improper fraction. So 6 times 6, 36, because these 4, they are gone. 6 times 6, 36. 36 plus 11, that is 47 over 6 times minus 6 over 5. So the 6 is gone. That's equal to minus 47 over 5. Or as a mixed number, I can just write here, the answer is minus. How many 5 do we have in 47? It is 9. 9 and 2 over 5. That is the final answer of this calculation. So the answer is equals minus 9 and 2 over 5. Okay, next example, solution. Let's use blue here. Considering 1 over n minus 1 over n plus 1. Okay, and do this. All right, let me just label this sum by s. Okay, that's equal to s. Now, what is s? So first, if you notice here, the denominators, right? 2, 6, 12, 132. These numbers are, what is it? The product of two consecutive whole numbers. That is 1 over 2. I can write it as 1 times 2 plus 1 over 6, 2 times 3. This dot means times. Plus 12 is 1 over 3 times 4. Here we notice here, every denominator is just the product of two consecutive positive integers or whole numbers. So how about 132? 132 is, it's not 10 times 11, 11 times 12, right? So that is 11 times 12, because 10 times 12 is 120, 1 more 12 is 12, and they add them up, we get 132. So now using this one, actually here, if you notice here, what is this thing? We just write here, 1 over n minus 1 over n plus 1 is equal to common denominator is n times n plus 1. So the first numerator I should multiply by n plus 1, the second one by n. So that's equal to 1 over n times n plus 1. So if the numerator is 1, denominator is the product of two consecutive integers, right? You can just decompose this fraction as this. You can write this 1 over n minus 1 over n plus 1. So using this method then, the first one I can just write it as 1 over 1 minus 1 over 2, plus the second fraction as 1 over 2 minus 1 over 3, plus the third one, 1 over 3 minus 1 over 4, dot, 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 and the last fraction is 1 over 11 minus 1 over 12, right? So now if you just notice here, these fractions, right, negative half and plus half, the sum is equal to 0. Minus 1 over 3 plus 1 over 3 is equal to 0. Minus 1 over 4 plus 1 over 4 is equal to 0. Before 1 over 11, here we have minus 1 over 11, right? And plus 1 over 11. They are all equal to 0. So what is left here? We have only the first number because it doesn't have pair, that's 1, minus the last fraction, also it doesn't have a pair, 1 over 12. Let's see. So now if you simplify this, 1 is 12 over 12 minus 1 over 12. That's equal to 12 minus 1 is 11 over 12. So dot, 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 s is equal to 11 over 12. Okay. Gabriel, anytime if you have any questions, you can just stop and ask me, okay? So I can re-explain if any step is not clear. Again, in this question, considering this 1 over n plus 1 over n plus 1, right? What is this? If you just consider this 1 over n plus 1 over n plus 1. What is it? The common denominator is the product of two consecutive integers. Here we have n plus 1 plus n. Or if you just simplify this, 2 times n plus 1 over n times n plus 1. Okay. So again, let me just label this one by s and continue from here. So s is equal to 5 over 6, right? See here, 5 over 6. I can write it as this 6 is 2 times 3. So I can write it as 2 times 2 plus 1 over 2 times 3. And how about 7? 2 times 3 plus 1 over 3 times 4. Plus, how about 9? It is 2 times 4 plus 1 over 4 times 5. Minus, it is minus 11. 2 times 5 plus 1 over 30 is 5 times 6. Dot, dot, dot. And the last one is 99. 99 is, what is it? 2 times 49 plus 1. It's 98 plus 1. So how about 24, 25? It is 49 times 50. Because 5 times 49, 245, and multiply by 0. And using the above formula, right? Actually, it's just actually obtain this and prove, so I can make use of it. Equals the first one. Actually, I can just write it as 1 over n plus 1 over n plus 1. So that is, what is actually, if you notice here, let me just highlight this. See here, there's 2 and 2, and 3 and 3, and 4 and 4, and 5 and 5, and 49 and 49. Also here we have, what is it? N and n, but here it is n plus 1. So I can write it as 1 over n plus 1 over n plus 1. So using this, now I can just write it as, what is it? 1 over 2 plus 1 over 3 minus, let me just write in the parentheses, okay? Because we have minus here. The second one is 1 over 3 plus 1 over 4. Plus, next one is 1 over 4 minus 1 over 5. So it is plus, minus, here we have 1 over 5 plus 1 over 6. Dot, dot, and the last one is minus 1 over 49 plus 1 over 50. That's it. So now if you open the parentheses, what we have here? Here we have 1 over 2 plus 1 over 3. Next one is minus 1 over 3 minus 1 over 4, right? Because actually this minus acts on each term, each fraction here. Next one is plus 1 over 4, 1 over 4 plus 1 over 5. Next one is minus 1 over 5 minus 1 over 6. Plus dot dot continues minus 1 over 49 minus 1 over 50. So now if you notice here, again, so here 1 over 3 minus 1 over 3, it is 0. Minus 1 over 4, 1 over 4, it is 0. 1 over 5 minus 1 over 5, it is 0. So this will continue. So also this is equal to 0. And also these two parts actually is equal to 0. Because from the previous fraction is 1 over 47 plus 1 over, 1 over 48 plus 1 over 49, right? So that's why only we have here the first fraction minus the last fraction. And their common denominators is 50. The first fraction numerator, which is multiplied by 25, 25 minus 1. That's equal to 24 over 50. And so we can simplify this by 2, right? Both numbers are divisible by 2. Divide 24 by 2, it is 12. Divide 50 by 2, it is 25. So the answer is that's equal to 12 over 50. So that is the answer of this question. Okay. Another example, evaluates. It looks huge, but we'll try to find a shorter way to do this one. Actually, we did similar example in our previous classes. 4, 3, 8, 2, 1, 7. 5, 4, 1, 3, 9, 6. 9, 2, 3, 7, 1, 5. And 5, 4, 1, 3, 9, 6. 9, 2, 3. And I'll just actually, let me just first highlight, for example, 438. Where do we have 438? Actually, here I have, and also 217, also 217, and okay. And also here we have 541396, 541396, 541396, 541396. Okay. How about 923, 923, 715, 923, 715, and 923, 715. Okay. 615, 219. Okay. What am I gonna do here is, okay, let me just label the thing because writing every time a lot of numbers, it may not be so practical. Suppose that's, okay, A is equal to 438 over 217. Okay, B is equal to 541 over 396. And C is equal to 923 over 715. Okay, 438. Okay, it's gone. 438 is gone. 438, 438. We don't have here, right? Okay, and the 541. Okay, it's gone. 541. It's gone. 541. Also 541, right? And 923. Okay, 923 and 923 and 923. What is that here? 651. And let's say this D is equal to 651 over 219. Okay, so that's it. So now if I substitute, I don't know what happens here. Let's say the whole thing is equal to capital A. Okay, that capital A is equal to 438 over 217, that is A, plus 541, that is B, and 923, that is C, times 541 over 396. Okay, 396, that is B, plus 923, 715, that is C, and 651, right, is D, minus 438, that is A, 541, that is B, 923, that is C, and 651, it is D, right? And 541, that is A, no, 541 is B, so here we have B, plus 923, that is C. So now let me just multiply like this, okay? Here we have A plus B plus C, right? And multiply it by B plus C. Okay, you can just take it as X, and this one is Y plus C. So I can just do it like this, A plus B plus C, suppose it's a single thing, and multiply it by B plus C, plus multiplied now by D. So A plus B plus C times D, okay? Minus the same thing here, multiply this A plus B plus C, take it as a single term, okay? Multiply by B plus C, A plus B plus C times B plus C. And here, because of this minus, minus D times B plus C. So now as see here, these two parts are the same. A plus B plus C times B plus C. A plus B plus C times B plus C. It is gone. Now, if I continue from here in similar manner, equals. So now here we have A plus B, not A plus B, B plus C times D. So A times D, I can just write this A times D, plus here we have B plus C times D. Okay, I'm just taking this as two things. A like X, B plus C as Y. And minus, here we have D times B plus C. So B plus C times D, D times B plus C, they are the same. Also, they are gone. What is that here? A times D. So now by substituting this, I can evaluate this. So then, therefore, the capital A is equal to A times D. What is A? A is 438 over 217 times D. D equals 651 over 219. Which is equal to, and 3 times 271, that is 650. So I can just cancel them. What is that? Here it is 3. And 438 is divided by 209, that is equal to 2. So the answer is 2 times 3, that's equal to 6. So dot, dot, dot. The answer to this question is just 6. That is the power of using algebra. Okay, we are just using very simple algebra, labeling some weird or big or I don't know, not simple numbers by some letters, and after that simplifying this. And in our final step, and simplify and substitute the original values and to get the answer. Okay, let's continue, Gabriel. Let's do one more question. After that, we'll give 1 minute break. Arrange the following sets of numbers in descending order. Descending order means from the largest to the smallest, right? So from the largest to the smallest, which one is the biggest and which one is the smallest in descending order? It says that descending order. Okay, to do this one, actually 2009, 2008, over 2008, 2008, 2009, over 2009, and 2008, 2009, over 2008, 2009, 2008, over 2009. Okay. First, I can just start with A and C because denominators are the same, right? And here, if we compare A and C, right? Let's see here, A is equal to 2009, 2008 over 2008, and C, it is 2008, 2009 over 2008. So denominators are the same. Now we have to just compare numerators. But when we are comparing numbers, we have to start from the leftmost side, right? 200, 200 is the same. But here we are reading it as, what is it? 2 million, 9, what is it? 1, 2, 3, 1, 2, 3, 20 million, 92,000, right? So here 9 is greater than 8. And that's why from here, because of this, because of this digits, right? Because of this digits, A is greater than C. All right. Also immediately I can just compare B and D. And also you can write from here in B, right? 2009, 2009, but because of this 8, right? Because of this and 9, this digits, right? So from here, I can just write A is greater than C, and what is it? D is greater than B. No. So now let me just compare big numbers first, okay? And the first step, the second one, and let me compare A and D. Right. So to compare A and D, 2009, 2008. Okay, A and D. Let me just write like A like this. A is equal to 2009 and 2008 over 2008, right? Is equal to, I can just write it as 2009, 1, 2, 3, 4 zeros plus 2008 over 2008. And this, instead of this one, I can just write here 8, right? So that will be equal to, what is it? That will be equal to, this one is 2008 times 10,000. So 2008, 2008, they cancel each other. So here we have 10,000 plus 2008 over 2008, that is 1. And here we have 1 left, right? 1, 10,000. So 10,000 over 2008. Okay, because this 2000, this 2009,000, right? I can just write, instead of 9, I can write 8, and after that just add 10,000, right? Because let me just show here. This one I just wrote it as 2008, 1, 2, 3, 4 plus 10,000 plus 2008. If you just simplify this, we will get this number. In a similar way, how about D? D is 2009, right? So it is 2009 and the 0000 plus 2008. Let me just write 2008 as 2009. 2009 minus 1 over, here we have 2009, which is equal to, here we have 2009, 2009, they cancel each other, there's 10,000 plus 2009 over 2009, that's 1, right? And here we have minus 1 over 2009. So these parts are the same, right? And remaining part we are subtracting, but here we are adding, which implies that A is greater than D. So this implies that then A is greater than D. So that means that A is greater than C and is greater than D, D is greater than B. Now I can just write here that A is the biggest one, right? Just thinking, is there any simpler way? Okay, A is the greatest. All right, yeah, in this way, we can continue. Okay. All right, A is the greatest, but now I have another idea. I think that will be much easier. I'm just going to write everything as a sum of a whole number and a fraction. Okay, then we can compare much faster. Like for example, A, let me start with A. Okay, this A is equal to is 2008, right? So I can just write the numerator as 2008, 2008 plus, because here we have 9, right? Here we have 4 digits, and here we have 10,000 over 2008. Okay, if you just add this, we will get 2009 and 2008 again. So equals, now if you simplify this, 2008, right, is divided by 2008, and 2008 is divided by 2008. That's equal to what? If you divide this, 2008, here we have 10,000, and here we have 1, right? So that's equal to 10,001 plus, and here we have 10,000 over 2008. Okay. And here we have 3 zeros, right? Because we have 10,000 here. In a similar way, the second one is B. B is equal to 2008, right? I can just write it as 2009, 2009. Now minus, because it was 8 here. So that's equal to minus 10,000 over, here we have 2009. So that's equal to, again, 2009 over this. I'm just using this property, A plus C over A or B something, right? I can just write it as 1 plus C over A. I have this B here, A over B plus C over B. So that's equal to 1, 1, 2, 3 zeros and 1 minus 10,000 over 2009. And how about C? Again, similar way, 2008, 2009. I can write it as 2008, 2008 plus 1 over, here we have 2008. That's equal to, again, 2008, 2008 over 2008. That's equal to 10,000, 100,000, right? It is 100,001. 10,001. Okay, here we have 10,001 plus 1 over 2008. And the last one, D, again, the 2009, I can just write it as 2009 and 2009 minus 1, because here we have 2008 over 2009. That's equal to 2009 over 2009. That's equal to 10,001 minus 1 over 2009. Okay. So now if you notice here, right, actually this whole part, all of all these numbers are the same. 10,001, 10,001, 10,001, 10,000. Just we have to compare their fraction, right? But as you see here, the first one, A, we're just adding 2001 and we are adding this number, right? And that is 10,000 over 2008. And here we have 1,000 over 2008. And that's why, let me just write here, in descending order, dot, dot, dot. Actually, A is the biggest one. Okay, it's done. Now, how about adding also? Here we have C, right? We are adding 1 over 2008 to 10,001. So C is the second biggest. Also, it's gone. Now, if you compare B and D, right? B and D, here we have minus 10,000 over 2009. But in D, we are subtracting 1 over 2009. And D, we are subtracting a very small number from 10,001. But in B, we are subtracting a big number from 10,001. So D is the third biggest, and smallest of all of these numbers is B. So that is, we have arranged these numbers in descending order. Okay. All right, question 8, refer to the following figure, arrange the following numbers in ascending order. Okay, and so here A, it is between -1 and -half, and B is between -half and 0, and minus AC. Okay, so usually one idea is, how can you do this? You can just substitute any values. Okay, that's one simple way. For example, how can I compare this? Since it is true, right? It must be true for every number that you pick in the given range, right? For example, okay, just one simple example. For example, A. Yes, any number between -1 and minus 0.5. Okay, what is that number? For example, we have -3/4. That is minus 3.75, right? It's between -1 and minus half. And how about any number between -half and 0? For example, B, let's say that's equal to -1/4. Okay. And C, any number between 1 and 2, for example, let's say C is, we can take any number, let's say this 3/4. So now if you just evaluate these things, what is 1/b squared? 1/b squared is equal to 1/, -1/4 squared. That's equal to 1/16, that's equal to 16. And how about -1/b? -1/b is -1/4. Minus is plus, so that's equal to 4. Actually, it should be, I need to write -1/b. So -1/b is equal to -1/4. That's equal to 4. How about -ac? -ac is equal to what is A? -3/4. And what is C? C is equal to 3/4. So that's equal to minus is plus 9/16. So now we can see which number is the biggest. It says following numbers in ascending order from the smallest to the biggest. The first number is 16. The second one is 4. And the third one is 9/16, right? So which one is the smallest here? AC is the smallest. Second one is -1/b. And the biggest will be 1/b squared. Okay, that is one way to compare these things. Now, of course, if you say it's proof, then we can prove this. Here we have 1/b squared. Okay, it's just one idea to solve this kind of questions. Part B. Okay, if 2 times 1 minus a/3 and 3a minus 1/4 are opposite numbers. It says opposite numbers. They are opposite numbers of each other. Find the value of A. So we need to find the value of A. Okay, since opposite numbers means that two numbers are opposite, if A and -a, these numbers are opposite to each other, right? So using the definition of this one, that means that here then 2 and 1 minus a/3, right? If I multiply this by -1, it should be equal to 3a minus 1/4. So we are not saying they are equal, they are opposite of each other. That means if you multiply 1 by -1, it gives us the second number. Now from here first, let's just cross multiply. If you cross multiply 4 boys, here 4 times 3 is -8. -8, here we have 1 minus a is equal to 3 and 3a minus 1. Now expand the brackets and take unknowns to the left-hand side, numbers to the right-hand side. -8 times 1, -8. -8 times -8 plus 8a. On the right-hand side, 3 times 3a, 9a minus 3. And take 8a to the right-hand side and 3 to the right-hand side. Here we have 9a minus 8a. And here we have -8 plus 3, right? We are just adding both, 3 to both sides to eliminate 3 from the right-hand side. 9a minus a, that is a. -8 plus 3, that is -5. So that is the value of a, if the given expressions are opposite of each other. Okay, question 2. 3 plus 2a/5 and -2/4 minus a are reciprocals. Reciprocals of each other. Find the value of a. Reciprocal means that actually a/b and b/a, they are reciprocals of each other. Why? Because their product is equal to 1. Okay, yeah, that's really important to solve equations. Since it is so, that means that here we have 3 plus 2a/5 times, and here we have -2 over 4 minus a. That should be equal to 1 if they are reciprocals of each other. Now let's simplify the fraction. Negative 2 times 3, that is negative 6, minus negative 2 times 2a, it is 4a, over 5 times 4, 20, minus 5, that's equal to 1. And since one fraction is equal to 1, if numerator equals denominator, that is minus 6 minus 4a should be equal to 20 minus 5a. Take minus 5a to the right-hand side, minus 4a plus 5a. And here we have 20, negative 6 to the right-hand side, plus 6. Now from here, dot, 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 the value of a is equal to 26. Another example, if a minus 2b times 2c plus 3d equals x, what is the value of 6d minus 3a times 6d plus 4c? Okay, since it's given, I'll see here first, I try to simplify, okay, write the expression in the simplest form in this form. So here we have 6b minus 3a, right? Actually, if you just extract or factor out negative 3, what we have here? Negative 3, and here we have a left, minus here we have 2b, right? The second one, here we have 6d plus 4c. What is a common factor? 2 is a common factor. Factor of 2, and write them in alphabetical order. First C, here we have 2c plus 3d. Now, if you multiply them together, here we have 6b minus 3a times 6d plus 4c, right? What is 6b minus 3a? That is negative 3 and negative 2. Let me just write them as first numerical part, negative 3 times 2. And here we have a minus 2b. And here we have 2c plus 3d, which is equal to minus 6, negative 3 times 6, negative 6. And this expression is given, what is it? Is equal to x. So that's equal to x. So what is it? The given expression will be minus 6x. Okay, word problem. Michael walked to school from home at 3 kilometers per hour. Right after he arrived at school, he returned home to get something that he forgot, using a speed of 6 kilometers per hour. After that, after he picking up his stuff, the forgotten stuff, right? Michael walked back to school at 5 kilometers per hour. Find his average speed of his journey. Okay. First, of course, a lot of students make mistake in solving this kind of average speed problems. At first, we should answer the question, what do you mean by the average speed? Okay, what do you mean by average speed? Actually, average speed is, the definition of average speed is the total distance traveled over total time taken. That's the definition of, what is it? The average speed. So here, let's say we are talking about these things, right? It's Michael's home and Michael's school, okay? And actually, he traveled this distance 3 times, okay? The first one, he actually moved from H to S, right? In the second case, from school to home. In the third one, again, from home to school. This is his home, and this is school and school. And suppose that the distance between home and school is d. In the first case, he walked to school from home at 3 kilometers per hour, right? So the distance is equal to speed is 3. In time, I don't know. Let's say it is t1. Okay. The second case, he walked back from school to home at the speed of 6 kilometers per hour. That actually distance remains unchanged. His speed is 6 kilometers per hour. How many hours did it take? We don't know. Let's say it is t2. And again, after Michael walked back to school at 5 kilometers per hour. Again, the same distance. His speed was 5, and it took how many hours? You see, 3 hours. Okay, so now from here we can find the times, right? What is T1? T1 is equal to D over 3. Just divide both sides by 3. In the second case, T2 is equal to D over 6. And third case, T3 is equal to D over 5. And by definition, what is the average speed of his journey? Of his journey means the total journey, right? We just write here then as average speed, the average speed for the whole journey, right, will be equal to total distance traveled. Total distance is d plus d plus d over total time taken. Total time taken is t1 plus t2 plus t3. And now if you simplify this numerator, that's equal to 3d over denominator d is a common factor. I can just keep this outside the parentheses. Here we have 1 over 3 plus 1 over 6 plus 1 over 5. Okay, now d cancel each other. And what is the least common multiple of 3, 6, and 5? That is 30. Let's multiply numerator and denominator by 30. So here we have 3 times 30 over 30 times 1 over 3, that is 10. 30 times 1 over 6, that is 5. 30 times 1 over 5, that is 6. That's equal to 90 over 15, it is 21. And both numbers are divisible by 3, it is 30 over 7. Or as a mixed number, that is 4 and 2 over 7 kilometers per hour. That is the speed of Michael for the total journey, for the whole journey. Okay, question 5. When x equals 1, y equals 2, right? Ax plus by equals minus 5 equals 5. Let me just write ax plus by as this, and 5. The first case, right? When x equals 1, it is a times 1. When x equals 1 and y is equal to 2. So this expression will be a times 1. It is a. 2 times b, 2 times b, that's equal to 5. The question is, find the numerical value of ax plus by minus 5 when x equals 5 and the y is equal to 10. So the second case, and the question is, when x equals 5 and y is equal to 10, right? And actually here, as see here, 5 times 1, 5. 5 times 8 is 10. I think we will get something similar here. If you substitute there, here we have, instead of x, let me substitute 5, 5a. Instead of y, 10, it is 10b minus 5. Equals the first part, right? The common factor is 5. Just factor out 5. Here we have a plus 2b and minus 5, which is equal to 5 times. What is a plus 2b? We have just found in the previous one, right? That's equal to 5. So that thing is equal to 5. So here we have that's equal to 5 minus 5, which is equal to 20. So dot, dot, dot. The value of the expression when x equals 5 and y equals 10 is equal to 20. Okay. We have 6 minutes left. All right. Let's try to solve 2 more questions as much as we can. In the figure, a rectangle is divided into 8 squares. All of the figures, as you see in the picture, in the figure, they are squares. The side length of the smallest square is 4. Find the area of the rectangle. So it says that like the given one, it is a big rectangle. And it's divided into 8 squares. And the side length of the smallest square is 4. We have to find the area of the rectangle. Okay. So from here, since actually the side length of the smallest rectangle is 4, so let's say it is 4. And also this is 4, it is 4, 4. Okay. So actually here, these 2 small rectangles, right? The square, they are the same. Let me just start from here. Okay, their side length is, let's say it is a, and also this should be a, and also this should be a. At the time, this will be what is it? 2a. Okay, and how about these 2 squares? Also the same. Okay, let's say it is b. Okay, and also it is b. Also this one is b. And also this one is b. So this should be, what is it? It is 2b. Okay, it is 2b. And how about this part? Let's say the C, right? And also the C. Okay, so if it is C, this is also C. Okay, and the big one will be the C, right? Is C plus 4, and this will be C plus 4. Okay, that's it. So now we try to get a kind of equation. Since a rectangle, top and bottom, they must be the same, right? And what is this side actually? This side is C plus 4. Also, this C plus 4, right? So C plus 4, it is A. Okay, good. C plus, all right. So let me just write here. Okay. Since the rectangle opposite sides are equal, top, it is 2C plus 4. Bottom, it is 2A plus 2B. Right, from here, if you divide both sides by 2, so here we have C plus 2 is equal to A plus B. What we are going to find here is actually the area, right? Anyway, the second step is left side is equal to right side. Left side is A plus B plus C. That is A plus B plus C. The right hand side, it is B plus C plus 4. Okay. Now from here, we can find the relation between C and B, right? So what is it? We know that from the previous one, A plus B is equal to C plus 2. So here we have C plus 2 plus C is equal to, what is it? B plus C plus 4. So the C cancels each other, and to take 2 to the right hand side, what is C? C is equal to B plus 2. Okay. So if C is equal to B plus 2, again, you can just use this one, right? And number 3, instead of C substitute there, it is B plus 2 is equal to A plus B. On the right-hand side, we have A plus B. On the right-hand side, we have C plus. What is C? C is B plus 2. So from here, B cancels each other. What is A? A is equal to A is equal to 4. That's not possible. Where did we make a mistake? Okay, that is C. It is 4. If this one is A, also it is A. Okay, it is 2A. It is B. Okay, that's B do B. Oh, that's not equal to B, right? It's not equal to B. If it is 2A, this should be 2A. Okay, we made a mistake here. Okay, 2C plus 4 equals 2A plus 2B. So dot, C plus 2 is equal to A plus B. And the second one, left-hand side, 2A plus A is 3A. 3A plus C. The right-hand side, we have C plus 4 plus B. And C cancels each other. 3A minus 4 is equal to B. Let's say this B is equal to 3A minus 4. Okay. So if B is equal to this, okay, if I substitute here, I can get relation between C and also substitute there. C plus 2 is equal to A plus B. What is B? B is 3A minus 4. So from here, C is equal to 4A minus 6. Okay. So we know B in terms of A, we know C in terms of A. And B, okay, C. Okay, at the same time, if you look at here, the C, right, that's equal to 2A plus 4. So at the same time, also C is equal to 2A plus 4. So these two things are equal. 4A minus 6 equals 2A plus 4. Take 2a to the left-hand side, 2a, negative 6 to the right-hand side, it is 10. So dot, 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 a is equal to 5. Okay, if you know a, now we can write everything. Okay, if a equals 5, now from here, and b is equal to 3 times 5 minus 4. So that is 3 times 5 minus 4, that's equal to 11. What is c then? C is equal to, c is equal to 2 times 5 plus 4, that is 14. Okay, that's it. So now I can just write the area then. Area of the rectangle equals 2 times a plus 2 times b, that is 2 times a, that is 5 plus 2 times b. b is equal to 11. And times width. What is width? 3 times a, 3 times a, that is 5, plus what is c? c is equal to 14. Okay, so that's equal to, we just write here 10, 22. It is 22 times 15, 29. That's equal to 638 units squared. Gabriel, thank you very much. I think time is up. Okay, I wish you good luck. See you next time. Bye-bye. Gabriel, I see your question. Okay, let me have a look. Question 7, ACDB. 7. Yes, that's correct, ACDB.